Hello and welcome back to question 3, trigonometry. So we are supposed to solve an equation. It says 7 cosine theta over 2 is equal to 10 sine theta for values of theta between 0 to 2 pi inclusive. So what this means is that there are some values of theta. If you substitute into this equation, it makes the equation true. Right, for example, if I substitute 2 pi, then this equation is not true because you have 7 cosine pi, which is equals to -7, and 10 sine 2 pi, which is 0. So -7 is not equal to 0. So that is not a solution. But if you substitute things like pi, right? 7 cosine pi over 2 is 0, and you have 10 sine pi. That is also 0. So pi is one of the solutions. So how do we solve this kind of equations? To solve this kind of equations, conceptually in your head, you should be thinking that if I were to manipulate the equation, I want it to ultimately look like either sine of x, cosine of x, or tangent of x equals to a numerical value, maybe 0.58. That is what I'm looking for. Right? I need to manipulate until this stage. Then the next step will be to sine, cosine, or tangent inverse the 0.58. Right? So with this in mind, and we look at the question we're given, we have a few difficulties. Number one, the angles are not the same. Okay, or rather, I'm going to call this the argument. The argument is the angles that we put into our trigonometric functions, right? The argument here is theta over 2. The argument here is theta, right? So first of all, I need to resolve that. I need to change both of them either to theta or both of them to theta over 2. Next, I have a sine and a cosine. How can I combine them together to make just one trig function? Now, some of you might have the answer in your head. Tangent, right? Maybe sine over cosine. So let's look at how we can do that. So first of all, what can I do to turn, say, theta over 2 into theta, or maybe theta into theta over 2? And you might be thinking about the double angle formula. And that's exactly what I'm going to do. Right? The double angle formula states that, okay, if I sine of 2a, of double the angle, double the argument, that's equals to 2 sine, single argument, single argument. Right? So I'm going to make use of this to substitute into here. I'm going to change it to 2 sine theta over 2 cosine theta over 2. So bringing this equation down, I got 7 cosine theta over 2 equals to 10 times 2 sine theta over 2 cosine theta over 2. That's 20. Sine theta over 2 cosine theta over 2. Okay, and here is where some students might make the mistake of dividing by cosine theta over 2. You shouldn't do that, because when you do that, you lose one solution. Right? So whenever you have the equation, try not to, whatever you're solving for, theta over 2, try not to divide by that. If you divide by that, you'll lose solutions. Okay? So what I'm going to do instead, I'm going to bring 7 cosine over to the right hand side. Then I can factor it out. This side is 0. If I factor out cosine theta over 2, then I have 20 sine theta over 2 minus 7 equals to 0. That tells me either cosine theta over 2 equals to 0, or sine theta over 2 equals to 7 over 20. Yeah? Okay? Remember, this is what I want. A single trig function equals to a numerical value. Right? I have it both over here and over here. Alright? So the next step is to solve. But before you solve, we also need to take note of this. The range of values that's acceptable for theta is between 0 to 2 pi. And now I'm solving for theta over 2. That means the acceptable values for theta over 2 is going to be between 0 and pi. Right. So let's do this. So between 0 and pi means I'm looking at the first and second quadrants only. Now I want cosine theta over 2 to be 0. That has to be theta over 2 equals to pi over 2. That is the only solution I'm going to get. If I think about it in terms of all 4 quadrants, then I have another answer at 3 pi over 2. But that is out of the range that I'm given over here. So just pi over 2. Now, next, for this side, I'm going to get 2 answers because I have first quadrant and second quadrant. So instead of saying theta over 2, I'm going to use alpha to represent, right? Maybe sine inverse 7 over 20. And that will actually give you 0.35757. Right, so this is worked out with a calculator, of course. You sine inverse 720. Okay, then I'm going to get 2 answers. One is in the first quadrant, which is 35757. The other one is in the second quadrant. To get the answer in the second quadrant, we take pi, which is 180, minus away whatever we just found, 0.35757. So the second answer is this. Alright, and rearranging everything, this actually is equals to 2.7840. Okay, which means theta is going to be pi. This is going to be 0.71523SF, and the other one is 5.57. So theta equals to 0.715 pi 5.57. Okay, that is the answer for part A. Now let's look at part B. Part B, we have to prove, right, the left hand side equals to the right hand side. Now for proving questions, generally I like to start on the side that has more terms. It means that I can, do more manipulation, I can change more things than the other side. And if you look at this question, for the right hand side, it's really empty, just half. It's hard to, move things around when you have much things to move. Okay, so I'm going to start from the left hand side. Okay, and looking at the left hand side while copying down exactly the question, you see a lot of secant x and tangent x. So you should be reminded of some kind of identity that links secant and tangent. What is that? Okay, so you might be thinking of, okay, I also see a lot of squares. So that should remind you of the Pythagorean identity. So the Pythagorean identity at the side, very quickly, you can write this down. Sine square theta plus cosine square theta equals to 1. Now, there are different forms. This is the first form of the Pythagorean identity. The next form is to divide throughout by cosine. Okay, I can also divide throughout by sine, but what I really want is divide throughout by cosine. Why is that so? Sine square divided by cosine square is tangent square. Aha! You might see why. This is the form that I want. Tangent square theta plus 1 is equals to secant square theta. Okay, this is the form that I want. This will be the most useful to me. I'll be using it maybe in the second to third step. But first, for the first step, I'm going to expand the denominator. So the numerator stays the same. And then the denominator, right? Opening up the brackets, I get tangent square plus 2, tangent x, secant x, plus secant square x plus 1. Okay, and you can kind of see, let me just use the highlighter here. This tangent square x plus 1 is equals to secant square in the denominator. Let's replace that. Then I have secant x, tangent x, plus secant square x in the numerator over 2 tangent x secant x, or maybe I'll write it as secant x tangent x to make it a bit more obvious, plus secant square x plus secant square x, 2 secant square x. And then from here you can see that it's really just half, because I have one copy of secant x tangent x, I have 2 copies of secant x tangent x at the bottom, plus 1 copy of secant x square x and 2 copies at the bottom. So the bottom is twice, exactly twice of the numerator, and that's 1 over 2. Don't forget to wrap this up by saying that this is actually the right hand side, and thus we have proven this. Right, so that was question 3. Hope that helped. I'll see you in question 4.